All right, guys. 2.1. 2.1 is all about rates of change and limits. And this is going to take a few days. So we'll go into after Labor Day with this. And this is now getting into calc. So the pre-calc stuff, we did that whole chapter in 2 weeks. We are now slowing it down and taking our time with the calculus. Got it? So now we are starting the intro to calc. But we're going to start off with something that we actually already know, a rate of change. So what's going to happen is we'll start with an example. Let's say we're going to drop a ball from the top of a tower. I want to find the velocity of the ball at 5 seconds. That's the big thing. First of all, velocity. Velocity is just speed with direction. Speed is just a rate of change. Rate of change is just another word for slope. So we're going back to good old slope, where I want to know what is the slope of the ball, the rate of change of the ball at 5 seconds. Got it? Now, to do this, we first need a formula. The formula for dropping a ball from any type of tower, of knowing where it is S of t equals 4.9 t squared. You guys should have hopefully seen this 4.9 thing before, hopefully in your Algebra 1 or Algebra 2 classes, or maybe in your physics or science classes. This is gravity. This is gravity bringing the ball down to the ground. Got it? Now, the issue here is, for us to find slope, you've always found slope with 2 points. I'm asking you to find it at 1 point after 5 seconds. Got it? Well, let's get really, really close to 5 seconds. Let's figure out the slope from 5 to 5.1 seconds. So you're going to use slope, basic slope, y2 minus y1 over x2 minus x1. So that means you're going to put in 5.1 into your equation and 5 into your equation. That's your y2 minus y1 over 5.1 minus 5. That's your x2 minus x1. So 5.1 is going in for t squared. So you're going to have 4.9 times 5.1 squared minus 4.9 times 5 squared. Those are your two things you're going in for t over 5.1 minus 5. Again, that's your y2 minus y1 over x2 minus x1. So solving that, you get 49.49 meters per second total. So I did the whole math for you. Got it? But the thing is, this is still from 5 seconds to 5.1 seconds. This is not really telling me what it is at 5 seconds. So this is what we're going to end up doing next. All right, so now here, what we're going to end up doing is creating a time interval where I'm going to get as close to 5 as possible. So I'm going to figure out time interval and figure out the average velocity. We already did the first one. We're going from 5 to 5.1 seconds. And I already know it's 49.49 meters per second. We created that. Well, let's get closer to 5. Right? So how about we go from 5 to 5.05. Do the same formula, the y2 minus y1 over x2 minus x1. This time I get 49.245 meters per second. Well, let's get even closer to 5. So I go from 5 to 5.01. Well, that gets me 49.049 meters per second. Hopefully you guys are starting to see something here. Kind of a pattern. Let's get even closer to 5. So now I'm going to go from 5 to 5.001. And that gets me 49.0049 meters per second. So hopefully you guys can tell that this is actually coming to a pattern. I'm taking a limit. As my time is approaching 5 seconds, as I'm getting closer and closer to 5 seconds, my average velocity is getting closer and closer to 49 meters per second. So that becomes my instantaneous velocity. That's my velocity at an actual point. What's my speed at 5 seconds? So when time equals 5 is defined to be the limiting value of these average velocities, there you go, to be the limiting value I can then say my average velocity is approaching 49 meters per second. So as t gets closer to 5 seconds, the average velocity, or the velocity, gets closer to 49 meters per second. It approaches 49 meters per second. So this was kind of like, that whole table was just a way to show you guys where like limits actually come from. We still have to do a mathematical proof of this, like now a real actual proof. So now we're going to go from 5 to 5 plus h seconds, where h is a ridiculously small number. So like our last one, h would have been 0.001, so that's how I got 5.001. But I want h to be even smaller than that, like 0.000001. So I'm not going to write 5.0000001. I'm just going to write 5 plus h, where h is ridiculously small. And now to find the average velocity, I'm still going to use the same things we've done before with slope, using the same equation, except now I'm plugging in the 5 plus h into time as well as 5. So I have 4.9 plus 5 plus h squared minus 4.9 times 5 squared. That's y2 minus y1 over x2 minus x1. My x2 is still 5 plus h. Minus 5 is my x1. So now let's simplify this. Well, the bottom's easy. What happens to the 5's on the bottom? Well, 5 plus h minus 5. Those 5's are just going to cross out, and I just have h there left on the bottom. Now the top, we have to do some work. I'm just going to rewrite it, or I'm going to rewrite the 4.9 there. And I want to figure out what that 5 plus h squared is. And do not tell me it's 25 plus h squared. That is not what that is. 5 plus h squared is 5 plus h times 5 plus h. You have to FOIL that, or do a sneaky square, or whatever else it is that you guys learned how to do this back in Algebra 1 or Algebra 2. I'm going to do FOIL. So 5 times 5 is 25. That's the first. Outside will be 5h. Inside will also be 5h. Last will be h squared. Combine my terms, that's 10h. So back in my parentheses, I get 25 plus 10h plus h squared. Minus, I still have my x1 of 4.9 times 5 squared. I'm going to erase all that there on the side because I'm going to need that space at some point. No, the eraser sucks. All right. So 4.9 times 5 squared, that's still my x1. Now I can simplify this. I'm going to distribute that 4.9 into everything in the parentheses. So 4.9 times 25 is 122.5, plus 4.9 times 10h is 49h, plus 4.9h squared, minus 4.9 times 5 squared, that's 25 times 4.9 is 122.5, all over h. All right, start canceling things out. What can I cancel out? The 122.5s can go. And I also noticed that everything has an h. So I can factor out an h. So that leaves me with 49 plus 4.9h all over h. Now what happens to h over h? That can go. So I get 49 plus 4.9h. Plus, not that. 49 plus 4.9h. Now remember, what's the deal with h? H is ridiculously small. I want h to be almost nothing. I technically want h to be 0. So that way it can get to me at 5 seconds. Right? So I want that h to be 0, become small. So what's 4.9 times 0 is just 0. And what's 0 plus 49 is 49. So as h decreases, what's happening to my velocity? Like we said, that 4.9 times 0 is gone. My average velocity gets closer to 49. And there you go. That's a limit. You guys just took a limit, the actual mathematical proof of it. All right, so we can now define limit. I'm not going to do the full-on definition of it. You guys can see it in your book. But limit is written as the limit as x approaches a of some function, f of x, equals L. Got it? So as x approaches a certain number, my y equals a certain number. So in our case, the limit as t approached 5, as my time got closer and closer to 5, my velocity got closer and closer to 49. That's how we figured it out. And we can do some examples right now. Let's see. All right. So first example is, let's take the limit. Or first let's look at f of x equaling x squared minus x plus 2. And you got to be able to figure this out multiple ways. So we're going to first do the limit as x approaches 2 of x squared minus x plus 2. One way is pretty easy. The algebraic way is you guys can just plug in 2 into this. So you get 2 squared minus 2 plus 2, and it equals 4. Ta-da! You guys just took a limit. That's considered the substitution method. Very straightforward, very easy. The other way you guys have to learn how to do this is the graphing way. So you go to your graphing calculator. In y1, you guys all know how to graph. In y1, you guys are going to go to x2 minus x plus 2. So go to y1 and then plug that in, and then graph. Put the graph in your calculator. Figure out your windows, whatever else that you guys have to do. Then you're going to press the trace button. And all of you guys should have trace, whether you have a Casio or a TI, you guys should have a trace button. Press trace. And after you press trace, you're going to press 2. Because it's going to say, okay, x equals what? You're saying x equals 2. Press enter on it. And then it should pop up what your y equals. So when x equals 2, your y equals 4. Ta-da, you guys just figured out your answer. Very straightforward, very easy example. Got it? Now let's do one that's not that easy, not that simple. All right, so this one might take a little bit more work and you knowing your unit circle. So let's figure out the limit as x approaches 0 of sine of x over x. So algebraically, you just want to plug this in and see what you get. Well, when I plug in 0 for sine of 0, again, this is you knowing your unit circle. What is sine of 0? Yep, it's 0. Over, well, if that x on the bottom is 0, that's also 0. You get 0 over 0. You can't do 0 over 0. That's what's called an indeterminate. It means you have to do more work. Now, your answer is not more work. Your more work is actually you putting this in your graphing calculator and figuring out more work, doing more work to get your answer. Algebraically, when you guys are a couple months older, we'll know how to do this and put it in our calculator, or put it and do it algebraically without knowing a calculator. Right now, you guys don't have the information for that. But today, you're just going to do more work by putting this in your graphing calculator. So go ahead. Go to your graphing calculator, go to your y1, and put in sine of x. Make sure that x is in parentheses over x. Over x is division, so it's really sine of x divided by x. Got it? And then graph it using a standard window. Now if you graph it, I believe you guys should get something that kind of looks like this. Now, press trace. We're going to do the whole trace button thing again. When you put in 0, though, you're going to get something blank or an error. So you press trace, you press 0, then you press enter, and then you're going to realize you're going to get an error. I'm not surprised by this. We knew we had an indeterminate, but your error is either going to say x equals 0, y equals blank, or y equals error, depending on the calculator you have. Again, not surprised. This is an indeterminate. Could not solve this. But this is us having to do more work. Well, the more work, remember, this is a limit. It's as it's getting closer to 0. So you guys have to pick things in your trace button as you get closer and closer to 0. So maybe you do traces of numbers close to 0, like let's see. Here you go. Trace, and then you do 0.01. See what the y equals there. Go closer. 0.001. See what the y equals there. Go 0.0001. See what the y equals there. And hopefully you guys notice that as your x's got closer and closer to 0, your y's were actually getting closer and closer to the number 1. That is our answer. That means as x gets closer to 0 on this graph, the y is getting closer and closer to 1. So if I go back to the top now, from this indeterminate here, I'm saying my answer is 1. And there you go. That's the more work. Again, so on your quiz next week, don't sit there when you get a 0 over 0 and be like, oh, it's more work, and that's your answer, and leave it. No. You actually have to go, do the more work, and figure out what the actual answer is. All right, so in your book, go to page 58. There are properties of limits. Actually, it's not page 58. It's page 61. It's actually page 61. You're going to go properties of limits. I'm not going to go over it. It's just like how to add limits, subtract limits, like the basic stuff. Go ahead and read all of that. And then tomorrow we will do more examples of limits and how to plug them in and the different answers you can get. See you guys then.